124. Okay. So kindly please make a note on this one. Yesterday we started discussion. Yeah. Now we done these are all. What are topics we done yesterday? So I have explained about the SPACY flow. Sorry. What flow I have explained? SPACY flow. First we'll get a string data. What data, sir? String data. Then from that string data we'll get as a SPACY document. And then from that the next one will be tokens, actually group of tokens. Or that every token we need to apply, which is so called as an attributes actually. What is that, sir? Attribute. And here Daniel, I wanted to convert the token into string, then you need to call as a text attribute. I wanted to check is the token contains alphabets or not, is alpha. Is it is it stopword or not, I need to check. Is it punctuation or not, I need to check. By looking at this one, you have to get a clear picture. There are more attributes are working. There are more attributes are working actually, right? Now this one is called as a checking the lemmatization. What is that? Lemmatization also we done actually. Okay. Now word frequency analysis also we done, I guess. Okay, so counter predefined class also we done, I guess. Parts of speech tagging. Good, fine then. Did you remember same topic even we done by using NLTK? By using what? NLTK also we done. Right. Now by using SPACY also, let us just try to so implement this topic actually. Here each word has its own role in a sentence. When you're talking about this one, each word has its own role in a sentence actually. For example, Daniel is dancing. So Daniel is a person and which is so called as a noun, and dancing is an action performing by him actually. So it is called as a verb, right? Likewise, each word can be classified. That classifying word is called as a POS, parts of speech. What exactly, sir? Tagging actually, tagging, right? Now parts of speech tagging: noun, verb, adjective, pronoun, adverb, preposition. These are all things we can do. Let me take one small example. You will get an idea. Very good, sir. Very good. Daniel, I wanted to apply POS, parts of speech. Very simple, man. I hope you already know. From the token, you need to apply one attribute. That attribute is so called as a POS underscore special attribute actually. One more new attribute. One more new attribute actually. POS can be implemented by using both SPACY and NLTK. First, let me see the method, by using SPACY. What is the technique actually? In SPACY, the POS tags are present in the attributes of token object, and we can access POS tag of particular token through the token of what exactly, sir? POS attribute actually. Come on. Parts of speech by using SPACY library. Let's do this actually. Parts of speech. By using SPACY. By using what exactly, sir? SPACY. Yeah. Let's take this one and import SPACY. Now we are loading the model. Can you talk with me? What is this one? A equals to spacey dot load. We have created and we are loading the model actually. Now let me take the sentence. The sentence would be B, which is so called as a Daniel is singing loudly and his roommates are what exactly, sir? Enjoying too. That's fine. Can you tell me the next step actually? C equals to A of B. That's you already know. Can you help me for T in Chappan sir? T in C. Then you can just have to get what exactly T. Every token. Am I right? Come again. Oh, good case, sir. Good case. Let us apply unique case actually. Let us apply unique case. We are getting all tokens. A lower case required to check stop words. To check stop words. But anyway, good. This is good practice. Good. Daniel is singing loudly. So and so word would he have? Now, Daniel, I just wanted to apply what I wanted to apply, sir. Either it is, I wanted to apply parts of speech actually. Now, wow, very good. Can you talk with me? What is this one? Daniel, pronoun actually. And singing is what exactly? Verb. And enjoying also what exactly? Verb. I wanted to filter only the singing and enjoying, sir. How to do actually? Okay, by this time you should know. Now here is a POS is an attribute. That's what you need to be understand. Okay. Move on to the next one. How to filter that one, sir? Take this one. If this word is matching with what word, sir? A word match only web. Then just try to get the token. Get that what exactly token actually. Yeah, you are filtering only webs that you can do actually. Okay. Now move to the next one. We'll do one thing. Let us apply same topic on kind of some text data. Let us take two paragraphs. We need to load that data. Then here, what we can do, we can just hit to apply. We are applying that word should not be stop word. That word should not be punctuation. Then we will get all these are words actually. Group of tokens we are getting. Then now here we are filtering where are all nouns would you have, where are all verbs would you have. Such a great sir. We are filtering actually. Are you ready? Come, let's do this. Let's do this so that you will get a clarity. Online team, get ready, sir. Get ready. So there is a one text file we are going to create, covid.txt. Even as the UK become the first country to grant emergency, blah blah blah. Kind of some vaccine discussion. What discussion? Vaccine related discussion. Let me take this. COVID. Go to the coding. Now let us just to run this. Sir, as it is, as usual. Come on. Import spacey. We are importing the spacey. The next one. A is ready. Previously B we hard coded. Previously B what done, sir? We hard coded. Instead of that one we are using by this one we are loading the file actually. This is so called as a so B. Perfect. Perfect actually. With So and so file we are loading. Now as file b equals to file dot what exactly read actually. Any idea c equals to a of b, that's it. A of b actually. Now do you want to print the c actually? Yeah, paragraph number 1 and what exactly, sir? Paragraph number 2. There are two paragraphs you can see actually. I mean, we are able to capture the data first of all. Did you notice? Sir, we are loading the data. Output. Why? Tell me why. What is the question? These are all of. Huh? It will come, sir. Why? Because as it will read actually. What's wrong in that? Good. Anyway, valid question. Open this. Here, this is the file. Here would have a quotations actually. That's what we are getting. Okay. Yeah. Good. Now, Daniel, we have loaded the text data. We have loaded what exactly? Text data. Once you loaded the text data, as usual, just like try to process the data actually. Try to process the data. We are just trying to doing processing. I'm sorry, sir. How you are processing? Daniel, let us just to get the word. I mean to say tokens from the C. Now I wanted to check token. It should not be stopword token. It should not be punctuation. Get the token. Get what? Token. Now get ready. Result. Yeah, nice. Any idea why no double quote and single quote? Very good. Tokens actually. I need string data. Then what I need to do? Dot text. Dot words are text actually. Instead of the text file, we have a here it is the result, right? Over this one you can apply. Over this one you can apply. Let's try this on top of this one. Attribute error or what we'll see. Okay, we have applied actually successfully. Okay, good. So take this one. Let me. Can I talk with online team? Online team, are you following or not, sir? What I'm doing, what exactly what we have done previously. I done the same discussion actually. Okay, this is great. This is good question. In a token, did you notice some back by any idea why two like this actually? Endukune telusa? Because if you open the text file, yeah, there are make a note on this one. Open the text file. Here you can see, sir, there are from here to here one line, from here to here another line. Two next lines actually. Next line. That's why we are getting actually. Sir, are you with me? I mean cursor here, so from here to here, two lines actually. Line number one breaking, line number two, then it is started actually. That's the reason. Okay, good. Okay, so let's move on then. Did I added this example here? Loading file, loading text file. Text file contains string data. Contains two paragraphs actually. Two paragraphs. Yeah, we have loaded successfully. Now, so applying text analytics. Applying text analytics. by using SPACY library. What library is a SPACY library? That's fine. Let's move on. Hope you understand. Okay. Okay. All right. All right. Let's move on. Sir, on top of these tokens, it should be token. Then we can apply other token functionality. It should be token. Then we can apply other token functionality. Get ready to understand. On top of these tokens, I wanted to apply POS, parts of speech actually. Then what we need to do? First of all, read these words. Yeah. Then if it is a verb, you have to filter noun. If it is a noun, if token is the noun, you have to filter and we have to add into the noun actually. If it is a verb, you have to filter the verbs and you have to add into the verbs actually. Instead of this, we can use list comprehension also. Instead of this, we can use what exactly, sir? List. That's still possible actually. I hope you know that, right? If you want, let me just try to run this example. You will get a clarity. Noun, I just wanted to add separately. Verbs, I wanted to add separately. Let's apply this. Online team, I request you please focus on this. Daniel, verbs. First nouns, that's still okay. Equals to, yeah, list comprehension. P1, P2, P3. చెప్తారా sir? For T, can I make it this one will be T1, 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 T1. That's still okay, no confusion. This one should be T2. In, చెప్పండి sir. Result, very good. You understand, I guess. Now the next one would be, what is the next one, you can just have to come here. Here you're writing if, so T dot POS, sorry, T in the sense POS underscore double equals to, any idea, sir? Chaptara? Noun. Yeah. Then get that token actually. Check that nouns. Perfect. These are all nouns. These are all nouns. And I wanted to capture, what is the next one? Verbs. Simple, sir. Same thing. Copy paste. Any idea here? Let us make it T3 for your more clarity. Sir, such a great example. Very good. I need your help actually. What is the first one? Nouns. What is the next one? Verbs. And anyway, these are all again tokens. Daniel, I need a string. I don't want to apply any operation. Then go to the text. Now hold on. Can I ask you a question? Imagine if it is a text actually, I will give some time. Please, can you analyze the program? Imagine here I have given this one is a text. Then, can you analyze the program? Sir, excellent, sir. Next level practice. Next, excellent action. Very good. Attribute error. Other guys, did you understand? Why? Because you're iterating the string. Over the string, you are applying POS, which is not there, attribute error. Which is not there, what error? Attribute error action. Good. You should know. That's what I'm asking actually. Unfortunately, here you have given string. but here you're iterating. Then you should analyze, okay, something went wrong. Then make it, this one should be token. Making this one should be token. When you can convert into string, if you don't want to apply any further operation, then convert into string. If you don't want to apply any further operations, convert into what exactly? String actually. అప్పుడు మీరు string లో convert చేయాలి. Okay. I hope you got a clarity. Yeah, perfect. Make a note on this. Take this example. Let's move on. We are filtering. చెప్తారా సార్? Nouns and verbs from so from paragraph actually, from paragraph file. There are two paragraphs and make a note on this. Perfect. You got it, I guess. Okay. Yeah. Move on to the next one. Wow. There is one more good sentence. One more good example. Online team, are you following, sir? I need one response from anybody. I need one response, please. Yeah, good. Then let me continue. Go back to the machine learning. We have a features and we have a target. Every feature, it is having relationship with the target variable. Every feature, it is having relationship with what exactly? Target variable. In English sentence also, so every word, it's supposed to have a relationship with other word. There is a dependency with other word actually. See, what is the sentence? Daniel is teaching data science. Daniel is teaching. Otherwise, Daniel is singing. Now here, make a note on this one. Teaching is called as a verb. And yes, of course, who is teaching actually? These both are intercorrelated actually. That you can identify the graph. Identify what exactly, sir? Graph. I'm sorry, I hope you got a clarity. This diagram, do you want to draw? You can execute this example in Google Colab only, not in Notepad actually. Google Colab only. Google Colab only. Let's try. Let me try this. Did I cover Google Colab? Yeah. Let's just have to log in into the Google Colab first. So make a note on this. New notebook. Yeah. Okay. As usual, let me just have to please explain this one. We are importing SPACY. Yeah. C equals to this formula became very easy for you. Now do one thing, sir. Okay. So display equals to render of DOC. I mean to say C. And here display is a kind of some submodule that we have to import actually. Now we are importing that. Let us just have to run this. See, spend some time. Good. Very good, sir. Daniel is teaching what exactly? Python, right? There is a kind of some relationship you can see. First of all, it is recognizing automatically POS. What is the POS? Parts of speech. Now it is telling Daniel, this verb depends upon the, so proper noun. Yeah, proper noun, I guess, actually. Then the next one will be, auxiliary verb. And, the teaching, it is what he is teaching actually Python. A kind of some relationship you can draw. If you want, you can take a big sentence, then big paragraph you will get actually. Go back to the previously. Do you want it to write more? Sir, you will get a big paragraph actually. First of all, can I take this example? Execute this example only in Google Colab. Google Collaboratory. Okay. Yeah. Now let us just try to take run this. Oh my God. Did you notice? Big paragraph actually. A kind of some big diagram. Every word which is having relationship with other word actually. I'm singing. Singing and other guys are enjoying, right? Oh, very good, sir. Having relation actually. Are you with me? Good. So don't take big paragraph. If you take in big paragraph actually, you will get a big diagram. One word, how it is having relationship with other word. Hey Daniel, is it important? Not much important, but we can draw this relationship diagram actually. Okay. Online team, are you following, sir? Why does the model need to know POS? Okay. There is a one question. Model should understand, sir. Understand either it's human or action or product, something like this, right? Daniel is singing or teaching actually. Imagine this one you have given to the AI model actually. Now model, best example, this one is a robo. This one is what exactly? Robo actually, robo. Then robo supposed to understand, so who is Daniel? What is the meaning of Daniel word? What is the meaning of every word actually? Meaning of what exactly? Every word. Every word. Model should understand. Who is Daniel? What is teaching? Then it can do the prediction for the next word actually. You got clear picture, sir. I'm sorry. Why does model need to know POS in the sense? Best example, being a human, why we understand about the POS actually, parts of speech? Why? Because we are recognizing who is male, who is female. These are all recognizing actually. What is a product? Yeah. Hope you understand. Move to the next one. We done these are all. I'm sorry, sir. Let me. We done these are all. Now the next topic name is called as a NER. What is the topic name? Chaptara? NER. NER means named entity recognition. Named entity recognition. Okay. Named entity recognition. Good. That is so called as NER actually. Understand? Daniel, what do you mean by named entity recognition? Suppose we have a collection of news articles and text data. From these, we can capture company names, organization names, people names, product names, many things actually. Best example. From these, we can capture. Let us take a kind of some one article from newspaper actually. Then in that news article, politician names can be, product names it can be. There are some location names, company names. I wanted to filter. These are all things actually. Then this is so called as the name itself is talking NER, named entity recognition. Named what exactly, sir? Entity recognition. Now how to do that? Now what is NER? NER is the technique of identifying named entities in the text corpus and assigning them predefined categories such as a person names, location, organization. Sir, if you see the example, you will understand, sir. These are all. It's a very useful method, especially in the field of classification problem. And what exactly, sir? Search engine optimizations actually. And NER by using NLTK and what exactly, sir? SPACY library. Let us just to apply. NER you can apply by using what exactly? NLTK and by using SPACY library actually. SPACY library. Yeah, SPACY is highly flexible and advanced library. NER recognition, named entity recognition through SPACY is an easy. Understand please. These tags you have to remember. This example also we have to execute in a Google Colab actually. Right. So imagine if it is a company, best example, can I take one example, sir? Can I take one example actually? Look at my screen. Look at my screen. Sentence. The building is located at London. It is the headquarter of Google. Mark works there. He speaks English. Very good. In the given paragraph, can you tell me what is the London actually? London is called as a location. Backend location it is representing with org. Okay. I'm sorry, sir. Not org, GPA. It can be country, state, or mandal. These are all things actually. The next one. Next one, Google. In the given sentence, Google. Can you tell me what is a Google actually? Org. Org means organization. Okay, company. Next one, so-called Mark. Sir, it is recognizing he is the person. Then English. What is English actually? Language. Language. Such a nice man. Nice actually, right? Here I need a small clarity. Very important actually. Make a note on this one. Make a note. So little important. Of course, this one is what exactly, sir? Document. Inside this document, there is one attribute. Attribute name is called as ENTS. Means entities. Chappan sir. Take the document, convert into entities, convert into inside that entity, there is an attribute. Attribute name is called as a label actually. Please. I'm not talking like token contains entity. I'm talking like, this one is a document. Yeah. Convert into entities to get NER actually. Then you can iterate one by one entity. Over that entity, you need to apply label actually. I will execute this example. You will get a clarity. Example execute yes and chudandi. Let's apply this. Import SPACY. Okay. Yeah. Now the next one. B. C equals to చెప్పండి sir. A of B. Good. Now these are all what exactly mean? Tokens. Document we are printing. Document means group of tokens. Do you want to print one by one actually? Okay. These are all what exactly? What is the data type, sir? Chaptara? The data type is a? I'm sorry. What is the data type actually? Type of T. Chapter, sir, what is the data type? The data type is a token. Token actual. Now, what exactly we are doing, C dot, what is this one, sir? You are calling one attribute. Attribute name is called as the ENTS. What is attribute name? Means entities. Now here getting each entity. Let us print entity. I wanted to know what is the data type actually. Let us check this one. Check chaddan chudandi. Previously token. Now we converted into each token is called as what exactly, sir? Entity. Perfect, sir. It is filtering automatically. It is which is so called as a from the entity we are getting a span. We are getting what exactly, sir? Span actually. Kind of some token span. We'll do one thing. I just wanted to print this all. After you are printing this, E dot, what is the attribute name, sir? Label. I just wanted to print the label actual. Perfect example, sir. Give some paragraph. In that paragraph, country names, company names, product name, person names, and language names, it is capturing automatically. It is capturing what exactly, sir? Automatically, actually. Okay. You can just have to come here. Marks, Daniel and Marks. Daniel and what exactly? Marks. Works in there actually. See, both are, oh, separate company would have, I guess, actually, with the both names. So it is telling directly organization actually. Now, you do one thing. So anyway, what I wanted to talk with, so 1 minute. Marks works there, and Daniel is working working in Infosys or TCS. Let us run this. Sir, what I mean to say, get ready. Get ready, sir. Wow. Google is organization, Infosys is organization, Daniel is person. Now I have a question. I wanted to filter only companies. How to filter? Equal to? Perfect. Yeah. Let's do that. Applying N-year example actually. Now here, you can just have to take this. If, yo, sir. org. Then get that entity only. Person also you can filter. This is beautiful. Wow. Nice, man. Python string don't know. Don't know Google. But, Spacey knows very well. Okay. So, if you want, you can provide a persons also. How nice it is, sir. Very nice. Seriously, very nice. Named entity recognition. Okay. So, you can just have to take this and just have to printing, displaying only company names. Displaying only person names. చెప్పండి సార్. There might be one question I have seen. Hold on. We are not using lawyer. So here it is identify the names and places actually. When this is required, I'm sorry. Okay. We are not using lawyer method. Okay. Daniel, we are not using lawyer method, Daniel. Will it impact actually? No. Why? Because, lawyer method is required if you wanted to filter the stop words. Why? Because all stop words are what exactly? I mean, if you wanted to compare with the existing stop words, all stop words are in lower case. That's what we have converted in lower actually. Supriya Garu, did you understand? That's still okay. Yeah, then excellent, sir. Excellent actually. One more technique, then separate technique actually. This one would be, for example, Apple is a fruit and Apple is an organization, right? Let's take this example and we'll see. Okay, let's take this one. Is eating apple. The next one. Mark is working in Apple actually. We'll see. Otherwise, we can give same. That's still fine. Let us just try to recognize actually. Now, can I print this one? You will get a more clarity. We'll see. then more advanced technique is required. We have in Hugging Face, it is very easy. Let me just try to move on. What label I need to apply, sir? Attribute we need to apply. I'm sorry, sir. We need to try. Let us run this. Come again. I have said actually it is recognizing Daniel is person and APPLA. This one is not recognizing. Okay, 1 minute. Let us use I wanted to apply NER using SPACY filter Apple company and Apple fruit actually. Context based logic, since both use same words but mean different things actually. You can just to apply here, yeah, as it is lower apple and a label.org actually ent.entity and fruits. Okay, company apple, fruit apple, company apple, fruit apple. Some explicit logic also required. Can I use Hugging Face? Yes, absolutely. There is one more library actually. Anyway, so let me apply the logic. Maybe let us go for a SPACY library. Supriya Garu, some explicit logic is required actually. So why? Because so here we are using the same word. Here also same word and here also same word. What exactly? Okay, hold on. Let me just try to let's do little R&D. We are importing the SPACY. That's still fine, Daniel. We are loading English version library. Text data. Apple released a new iPhone this week. I bought some fresh apples. This one is the Apple. I bought some fresh apples from the market. Steve Jobs was the CEO of Apple. And Apple is a day, keeps the doctor away actually. Right, very good, sir. Check for named entity recognition. Use context to filter actually. It is taking entities and converting into lowercase. Okay, it is just trying to converting into lowercase. Comparing where all Apple is available. If entity dot label belongs to the organization, wow, it is filtering, sir. Then we are getting that filter. Else, great, sir. Else start equals to maximum entity start. There is a position we are giving. Max function you need to be understand, and the end function also you need to be understand. Context equals to doc of. There is some logic, sir. Any these are all okay. Okay. I got it. These are all again hard coding actually. Ma'am, one more point. I'm repeating, if it is not organization, imagine the same word repeated actually. If no organization, then the next word you can go for the fruit actually. But to make it fruit, there is some explicit logic. Check nearby words for the fruit context actually. Let me tell you the topic. The topic, what is the topic? NER, only for a kind of some, companies actually. The next one, countries. The next one, states. The next one, person names. Person names actually. But not fruit names actually. But not what exactly? But not to filter fruits. Not to filter what exactly? Filter fruits actually. That's why this specific logic. Otherwise, in one shot, there might be one attribute we can capture actually. Can I get a response from you? And if you want, still you can make it simple actually. So if you want, take this one. Do we have any other logic to make it simple, or use any other model? You can ask. 1 minute. Oh, sorry. Great follow-up. This is a simpler and a smarter alternative. Your current logic for manually checking nearby words. Here 4 options. Ranked for a simple. Oh, there is a ranking. It is giving ranking for word actually. Matcher. Matcher means again we need to go back, sir. So spacey matcher, press matcher. No, anyway, so at least let me try some one more model I can try and I can share the logic actually. That would be fine. But anyway, make a note on this one. By using NER, named entity recognition, you have to capture only these are all countries, companies, states, person names, but not to filter fruits actually. Okay, so let's move to the discussion. Good. Daniel, where are all we are getting this? Go back. Can I go back to the logic? Control Z. Let me just try to print that. Let us just try to print this one. Now I wanted to highlight Daniel. Is it possible? You can highlight, sir. You can highlight actually. You can highlight. How you can highlight, take the same sentence and you can just have to create a diagram. Go to the Google Colab. Yeah, you can just have to apply here. Now, what exactly you can do, sir? You can call kind of some display function you have to import actually. Yeah, you need to import the display. Then display.render, please be patient, see, display.render, see, I mean, we have created a document, right? Style equals to entity Jupyter. Come on, let us pause this and you can observe. Sir, I need your help, sir. Chapter, what is this? See, that's it. Let us run this. Did you notice here? Daniel, when you're talking about, see, it is recognizing, we can even cross verify. Raju is eating banana. Banana word is a very familiar word. Let us just have to make a note on this one. See, did you notice? So make a note on this one. So London GPE, Google organization, make person, Mark person it is recognizing. English language, Daniel person it is recognizing. Infosys organization, Raju is eating. Raju is the person name, right? It is not recognizing. Then more kind of some complex models is really required actually. Why? Because Raju is the person name. Why it is recognizing Mark and Daniel? Any idea? Any idea, sir? According to the English context and Mark and Daniel, even over the web you can see many words actually. Let's do one thing. International MA TTHEW. Let us just have to run this. First point I wanted to confirm, it is not recognizing banana. Yeah, Matthew also one of the famous name actually. Now I wanted to confirm by using NER, location names, person names, organization names only it will recognize actually. Raju, I'm sorry for saying kind of some local names actually. What names, man? Local names. But still the model is supposed to work based on the grammar. Why? Because eating. Who can eat actually? Persons can eat. Am I right or not, sir? That too, eating, right? Before that name, what exactly we have to filter actually? If you want, I can explain more complex example also. NLP project actually. I need a response, sir. Are you with me? Take this one. Sir, run this example in Google Colab only. Run this example. Write and run this example by what exactly, sir, using Google Colab. Google what exactly? Collaboratory. Perfect. Move on to the next. Now there is a one small use case. What are we doing here? So nothing, sir. So we are filtering the persons actually. Where are all person we do have? We are filtering that we already know actually. We are taking the entity and entity type equals to, okay. Not only previously NAR, in a document, in a document, we have a tokens. In a token, there is one attribute. Attribute name is called as what exactly, sir? Entity underscore type underscore. By using this one also, you can filter the person name. By using this one also, you can filter what exactly, sir? Person name actually. Person name. Okay. Yeah. Requirement. Let's do little R&D. From text, how to filter fruit names actually. Fruit names by using natural language processing. Write a Python code actually. A piece of Python code that would be fine for me. Let us just try to try this. Yeah, you can do little R&D. Okay, come on. Sure. Below is the simple but effective Python scripting NLP extract fruit names from the given text actually. Specific for tokenization, parts of speech, and you can expand it. Optional WordNet and WordDoNet actually. Fruit list, apple. It is hard coding, sir. It is hard coding. Where are all word it is available? It may be match, I guess. Chappan sir, ఏంటి? Explicit. Then later it may compare, I guess, actually. That's the best way. It is extracting each and every word. It is filtering actually. I am eating mangoes and bananas. Yesterday I bought apples, grapes, and watermelon. Stew brought a orange, but he is mentioned apple. Uh, but he also mentioned what exactly apple and new iPhone actually. Very good. So here fruits found banana apple. Very good, sir. Take this exam. Copy paste actually. Run this code. Let me tell you pure Python code actually. If you want, I can explain this one also. It's a very simple. Perfect. Can I explain? Look at my screen. Did you understand? Sir, that's the beauty. If you know prompting actually, prompting in the sense, first of all, what is the requirement you should understand. You have to ask in a proper way actually. Then if you're asking in a proper way, it will give the code. To understand the code, you should be master in technical. Then close the discussion actually. Look at my screen very clearly. SPACY library, that's still okay. NLP equals to SPACY. Perfect, sir. This we already know. And okay, hard coding. These are all fruit names. It is hard coding actually. Sorry. Right. Apple, banana, orange, mango, grape, pineapple, peach, cherry, so pear, then kiwi, papaya, lemon, lime. These are all. Function to extract fruit names. Great. There is a function somebody have written actually. What is that function name? Extract fruits, and the text we are passing actually. Text. These are all text we have passed. What is it? This text actually. I love eating mangoes. Okay. Eating mangoes and bananas. Yesterday I bought apples, grapes, and watermelon. I'm sorry, watermelon actually. Steve brought an orange, but he also mentioned apple, so and so INC, and new iPhone actually. Good. We'll do one thing. Then this function will be triggered. Then the text will be passed actually. Now here is a story. Any idea what exactly they are doing? Can I ask you a question? 15 line, what they're doing, sir? Converting into document. Am I right? Converting into document actually. This is something like a C equals to FB. Am I right? C equals to, do you wanted to know? This one should be A. This one should be, I need your help actually. C. This one should be A of what exactly, sir? B. B actually. That's what you need to be understand. Okay. Till here you know the logic actually. Then found fruits equals to set. Perfect, sir. Imagine they are creating any idea. Line number 16 is what? They are creating empty set. Chappane. They are creating empty set actually. Okay. For token in doc. Okay. So I hope you already know the document. What is a document actually? I'm sure this one is a document, right? For C actually. I hope you know this. For token in doc, if token dot lemma, why they are applying lemmatization? Why? Because they should find the root word. They should find Great, actually. They're finding the root word. Yes, of course, finding the root word case matters actually in fruits list actually. Perfect, sir. Frankly speaking, this is the solution actually. Best example, either it is a banana, bananas, mango, mangoes, uh, grapes, grape. Lemma helping here actually. Lemma, lemmatization is helping. Such a great example. Supriya Garu, did you understand? This is the way we can filter the fruits actually. Even it is ignoring, even it is ignoring apple and it is ignoring, so this word it is ignoring actually. Oh, sorry. If you want, I can share this example, spend some time. Other guys actually. Filtering. Filtering. What exactly? What we are filtering? Fruits from text data. The logic is very simple, sir. That's what you need to be understand. Okay. Fine. You need to spend some time. That's why. Uh, when when you can use. Okay. Who can do that? Who can do that, sir? Who can do that? Fine, then back to the session. Where are we? So I just wanted to filter the person names. Anyway, to filter the person names, you can just have to apply NER. Daniel, instead of NER, do you have any other alternative topic actually? Use the token and you can, there is one attribute name is called as what exactly, sir? Entity underscore type. If it is a person, then you can just have to get the person actually. Let me apply this. There is a one small use case. Get the string data. Perfect. Yeah. Get the paragraph. B. C equals to A of B. Okay. Now you can just have to list of peoples. Sir, wherever empty list and for loop, go to the list comprehension. Go to list comprehension. That's the best actually. Now the result equals to P1, P2, P3. Now for T in C, T in what exactly, sir? T, C. Now I need this, so we have to add this one directly. I need your help. Where all I need to do change actually. Chapter, sir, T. Then make it this one is what exactly, sir? T.txt. Perfect. Perfect, sir. You need to walk through. Oh, Twitter is person name. Twitter is what? Person name. Maybe in some other location. So make a note on this one. Take this one. Recognizing person names actually. Person what exactly, sir? Names. Okay. That's what you need to understand about the SPACY library. I have assignments I will share actually. Walk through that assignments. More examples would you have. Playing with the more text data. Playing with what exactly? More text data. Online team, did you understand, sir? I need one response from anybody. Did you understand? Yeah. Now, so let me target the pending topics actually. Go back to the once, go back. Machine learning, lasso regression and ridge regression is pending, right? We can close now. Slowly by slowly. It's very simple. We done this. And let me just try to make a note on this one. Model deployment also I will cover. Lasso regression and ridge regression. Let us keep this one is in heading actual. It is very easy. I will cover step by step. It is very easy. Now, Daniel, what is a prerequisite? What is a prerequisite actually? Prerequisite. Or else why this topic came actually? To understand lasso regression and ridge regression, to understand, to what exactly sir? Understand lasso and ridge regression. Ridge regression. First of all, we need to understand. We need to understand. We should know. We should know one topic. The topic name is called as a overfitting and underfitting. And what exactly, sir? Underfitting. Are you with me? Good. What do you mean by overfitting? Imagine we trained a model. We trained what exactly? Model actually. So during training, imagine, so during training, model is giving good score, high score. During testing, model is giving lesser score. This is so called as a overfitting. Am I right? The next one. Daniel, what do you mean by underfitting actually? What do you mean by underfitting, sir? Let's take the same. Let's take the same. Sir, both are what exactly? Less only. Both are what exactly? Less only. Right. Now here is the story. Lasso and what exactly? Ridge regression. Lasso and ridge regression are solutions to to fix overfitting issue. Overfitting issue. Okay, that's what you need to be understand. Imagine overfitting is a problem in a model. Overfitting is what exactly? Problem. Good. Then overfitting. Theory. Point number one. This is really problem in machine learning. Problem. Problem in what exactly, sir? Machine learning actually. Then we need to fix. Then we need to what exactly, sir? Fix this actually. Right. Then where is the solution? Where is what exactly, sir? Solution. The solution is, the answer will be, what is answer, sir? Lasso and ridge regression. I'm repeating again. Overfitting and underfitting are two issues in machine learning. Maybe a long back I have already covered actually. Am I right or not, sir? So long back I already covered. Low bias and high variance also. Am I right? So even somebody texted me. Exactly, you're right, sir. Low bias and high variance value. Supriya Garu. Yeah. Yeah, Siddiq Sarji. Fine then. Now, lasso and ridge regression. These two are the solutions. Sir, simple, sir. Lasso is one of the one of the machine learning algorithm. Ridge also one of the machine learning algorithm. Right. Good. Let me tell you. First of all, here understand why this issue important. Why model is facing overfitting issue. You are telling model is facing issue. There should be a reason, right? There should be what exactly, sir? Reason. Why model is facing issue? The answer is, what is the answer, sir? Due to large coefficient values. What values, man? Large coefficient. Yeah, coefficient. What exactly? Values actual. Imagine, let us go for linear regression. Whenever you are creating a model, whenever you are creating what exactly model will start generating coefficient values. Go to the gradient descent algorithm. Then gradient descent algorithm, slowly by slowly, it will update the coefficient value if the error is a very big error. If the error is what exactly? Very big error. Sometimes what happen, the coefficient values can be very large values. Very large value. even gradient descent algorithm cannot handle actual. It will tell, I'm sorry, it is out of my box actual. During that scenario, we will get this issue. Sir, I have a question for you. What is overfitting? Training, high score. Testing, less score. This is the definition. Now you need to give explanation why you are getting overfitting issue. Why? What might be the reason? The reason behind of this one will be large coefficient values. Why model is getting large coefficient values? Due to data errors. Due to what exactly? Data. It is also called as a data having some issues. Imagine there are some missing values you didn't handle properly. There are some outliers you didn't handle properly. During this time, model will get overfitting issue. Model will get what exactly, sir? Overfitting issue. I'm repeating again. Why model having overfitting issue? Because coefficients are very large values. That's the reason it is getting overfitting issue. Can you please elaborate normally? Yeah. If the data having missing value, please handle. Otherwise, it will face overfitting issue. If the data having outliers, please handle. Otherwise, it is facing what exactly? Overfitting issue actually. Are you clear? Good. Anyway, team, this I can cover in the next session. Maybe we have very short time. Tomorrow no session, right? Maybe I'm leaving early quickly today. We done today's session. Tomorrow no session. We'll connect again on Monday. Yeah, yeah. Let's can I upload here itself actually? Space is quite interesting. Space assignments. It is in my personal laptop. I will share actually. There is one NLP project also I will share. Thank you guys. So we done today's session. We'll connect again in the next session.